Okay, let's pick up from where we left off. We wrote S, the arc length, which is AB in our picture, is equals to the integral, the values of theta going from 0 to pi over 2, and we have this ugly looking expression here, the square root of 36 cos to the power of 4 theta sine squared theta plus 36 sine to the power of 4 theta and cos squared theta, and we have a d theta. Good. So now we need to solve this integral, or rather a more accurate way of saying it would be we have to evaluate this integral, and that will give us the length of AB, and all we have to do is don't forget to multiply by 4 and we're done. Okay, so let's do that slowly. Let's clean up this integral first. We have 0 to pi over 2 square root. Let's take out the 36. Let's do some factorizing. We have cos squared theta, sine squared theta, and I have cos squared theta plus sine squared theta. Great, things are falling into place. Yeah? I have a 36, I have a cos squared theta and a sine squared theta. So this one, just to check very quickly, so I have 36 cos to the power of 4 theta sine squared theta, and I have 36 cos squared theta sine to the power of 4 theta. Great. Okay, so this one, we know the value, it's 1. So now the square root of this is pretty easy. So let's write it out. 0 to pi over 2, we have 6 sine theta cos theta. Okay, the square root of 36 is 6. The square root of cos squared theta will be cos theta. The square root of sine squared theta will be sine theta, and we are done. Okay, so let's write d theta to make it more complete. Okay, so what we can do is, it's up to you how you want to clean up this integral. Okay, so what I'm going to do is I'm going to write it as 3, 0 to pi over 2, 2, let me write that again. Okay, I've taken out, this is 6, so I've taken out 3, so I'm left with 2 sine theta cos theta d theta. Okay, nothing changes. It's still 6 sine theta cos theta. Why did I do this? Because this one here should be pretty familiar to us. So this will be, let's write it here, 3, 0 to pi over 2 sine 2 theta d theta. Okay, so maybe I'll do that here. Okay, let's bring this up here. We have 3 okay, don't forget there's a 3 here, and we have a sine 2 theta d theta, so that will be equals to 3. When you integrate the sine, you'll get a negative cos, so I have negative cos 2 theta over 2 pi over 2, 0. Okay, when you integrate the sine, you'll get a negative cos, so you have it, negative cos 2 theta divided by 2, and maybe I should write it up here. Let's erase this. Okay, let me just erase this. Give me a minute. Okay, so I have negative 3 over 2, okay, cos 2 theta pi over 2, 0. Again, there's a negative here, I took it outside. There's 2 here, I took it outside. So it's negative 3 over 2 cos 2 theta. The upper limit is pi over 2, the lower limit is 0. Okay, I'll need the space, so let me just create some. Okay, good. So now I have negative 3 over 2. So plug in pi over 2. So I have 2 times pi over 2 will be pi. Cos of pi will be negative 1 minus. Plug in 0. Cos of 0 is what? 1. Good. So I'm left with negative 3 over 2 and negative 2, and I'm left with 3. Okay? Negative 1. Negative 1 is negative 2. Negative 2 times negative 3 over 2, we have 3. So this is the length of AB. Okay? The arc length AB. So therefore, total okay, length of curve, okay, will be equals to 4 times the first piece, and your final answer is 12 units. Okay, so don't forget to multiply by 4 because you have worked out the length AB. So they want the length of the curve ABCD, okay, the perimeter of this curve, and so we have 4 times 3, we have 12 units, and we are done.